Welcome back. In this lesson, we're going to look at the channels of the streams themselves. So whether this channel is flowing on solid rock and cutting into that rock, or whether it's actually onto a bed full of sediment, are the different types of channels. A lot of times that has to do with how steep that the channel is, how fast, how much water is being traveling, and what is being suspended in that water. So we'll look at these different kinds of forms. So the channel that a stream flows in is either going to be solid rock, and that would be called a bedrock channel, or it's layers and layers of sediment that's settled to the bottom of that stream, and that would be called an alluvial channel. So alluvium, remember, is the stuff that's deposited by a river. So the little particles, the bigger particles, the pebbles, the rocks, whatever is carried down by the river as a load is going to be settled somewhere further downstream when the gradient is lower and the water is moving slower. Okay, that would be an alluvial channel. Sometimes you're going to see sections of a stream that is steeper, where all of the sediment has already been dragged out, and the only thing that's left is the solid rock that stream is sitting on, and that would be called a bedrock channel. Then somewhere else in that same stream, you might have a more shallower or less steep area where pebbles and rocks and sediment has been able to settle, and then that would be an alluvial channel. So you could have different channels within the same stream. So in the case of a bedrock channel, the rock that makes up the bedrock determines what that channel is going to be like. If the bedrock is easily eroded, then you could have it could be very deep down. It could cut very far and very fast into the rock and carry a lot of that rock away. If it's a denser rock, less prone to erosion, then you may have a not as deep a gorge as you would. So remember, the bedrock channel is being cut. The hydraulic force of the water is actually cutting into the rock, and most of the coarse particles are already gone. But then as it cuts, then those particles are going. That's usually going to be really steep. And so depending upon what the rocks are like, if you would have a very hard rock where the water is riding, but then it erodes a softer rock lower down, you may have lots of waterfalls. You may also have rapids. Rapids, remember, is where it's steep enough for that water to be turbulent and rushing. Okay, depending also on the rock, you could have winding. The streams don't have to be solid or don't have to be straight. If all of the rock is the same type of rock, then it would erode about the same rate, and you'd have a steeper, straighter shot, a straighter line. If it's going from one type of rock into another, where one is more eroded than the other, then you may have a winding or irregular path. In the case of an alluvial channel, remember, an alluvial channel has sediment on the bottom. It really is dependent upon the sediment size. And remember, if you were to have a stream that would have sometimes lots of water in it and sometimes not a lot of water in it, to where in times of like high rain or whatever, it will rush lots of that sediment downstream, and then other times that it would be more regular, more normal, would depend upon the shape of the channel. The channel is based upon how much sediment is there at any one time. So there's two basic types of alluvial channels. You have meandering channels. So almost every river that you've ever seen is meandering. It's going to have curves in it. It'll go to the left and then round to the right and then round to the left again. Meanders are normally not in very steep places. The steeper the mountain streams you would have, the straighter they normally are. They would, of course, meander around a mountain. If you've got if you have a mountain and you have a valley at the bottom of that mountain, and that's where the river is, they will meander around the hills. But if you were to have a meandering river, normally it is a river that's on the same elevation. So it will simply go to the left and the right and the left and the right. In the case of, say, at the bottom of a delta, you will split up into, it looks like many different rivers, and that's called a braided channel. And you'll see that has to do with what is actually being laid down, what size of particles are being dumped. So a meander is going to be a river or a stream that flows to the left and then curves and goes to the right and then curves and goes to the left again, back and forth. So the speed of that water is going to be different on one side than the other. If you were to have a straight shot stream where everything is straight as an arrow, then you would have the sides, both sides of the stream would be going the same speed. But if you were to have a left turn, what will happen is anything on the right is actually going to be going faster than the stuff on the left. If you have a right-hand turn, your stream is actually going to be going faster on the left than it is on the right. So whatever the outside is, that's where the stream water is going to be flowing the fastest. That's where it's going to erode the most. So what will happen if you have a stream that turns to the left, the right-hand turn, the right-hand bank of that stream is going to be being eroded quicker. The left-hand stream, wherever you have the left-hand turn, that side is going to be going slower and more likely for the sediment to be deposited there. So you'll usually have a beach. If you have a left-hand turn, you'll usually have a beach on the left. If you have a right-hand turn, you'll usually have a little beach on the right. Okay, so what'll happen as it goes back and forth, it normally will, the outside will be eroded and the inside will be deposited. So the soil that used to be the stream bank is going to be cut out on the side, on the outside turn, and the inside is going to be slower and more likely for that material to be deposited. What that does is make the meander more and more pronounced. The longer that stream flows, the more turn you're actually going to get. And sometimes you can get such a turn that it will meet itself again. And that will be called a cutoff. And I'll show you a picture. Okay, so let's look on the center picture there. The center picture, you're going to have a straight shot where the stream velocity is going to be fastest in the middle, and the sides will be basically the same speed. If you get around a turn, what will happen is the outside gets faster. The outside is where the stream velocity is faster, and it cuts the most. And the inside is going to be slower, and it is, because it's slower, the sediments that's being carried in that water is more likely to be deposited there. So you'll have a beach on the inside curve. As that stream flows more and more and the outside cuts and the inside deposits, what will happen is that curve will be so big that sometimes it will cut off itself. So on the right-hand picture, you've got a cutoff where that bottom ribbon has been essentially so far back that it meets itself, and then it cuts off, and you have often what's called an oxbow lake. And an oxbow lake is simply what used to be the channel of that stream that's now just a little ribbon of a lake, where the river has cut it off again, the rivers continue to go down and then left it there, and you end up with a lake. If a stream is carrying lots of very large particles, okay, sand, gravel, bigger rocks, where there's lots of, the load is very heavy, and where sometimes you're going to have lots of fast water and sometimes slow water, what'll end up being is that it deposits that load in different places, and then it basically clogs up its own river. So the whole channel has been essentially filled up, and then the water overflows its banks and finds a new path. And so you end up with lots and lots of little stream beds everywhere. So the entire plain is then filled with little rivulets or little rivers that are coming off of that main river. That's called a braided channel. And you'll see that a lot of times when the ground is so flat that there's hardly any gradient at all, and whatever's material is falling down, the water then just finds another path. Okay. You'll also have this common at the end of glaciers, where water is coming not from one single channel, but from an entire area, and so you have lots of little rivers coming around from the braided channels. So this is a picture of a braided channel. You've got such dense sediment that it fills it up, and then as it fills up the bank, it floods, and it floods into another path and then dumps its particles, and then you just get river after river that's not one river but just a conglomerate of rivers, and that's why it's called braided. It looks like little fibers that are being braided into a rope.